This is a video walkthrough for the aluminum cube assignment. So the rubric for this is that the cube needs to be built to size. The initials are welded into the cube, that's supposed to say cube right there, and your class hour needs to be welded in. So think same thing that the aluminum cup is for the welding 1 class. So you have like for me, it'd be KTR would be my initials, and then I'd pick a class period. We'll say period 1. So it'd be KTR1. That's what you have to weld into the sides of your cube. All pieces need to be lined up correctly. This is, you need to build it correctly is what that comes down to. The outside of the cube is smooth. Welds don't need to be or have to be grinded or sanded smooth, but it does need to be smooth on the outside. Including your initials that you weld in, which would be like the last step for the whole thing. And then construction of the cube is square. I would recommend that as you build this, you consider, it's not required, but that you would consider grinding grooves into the edges of the cups where it's to be welded to the next thing, and every single seam has to be welded, so this thing's 100% welded all the way around. If you grind grooves into the sides of the metal, it's going to allow the metal to sit down into it, so then when you go to grind it, you're not just grinding off what's holding the whole thing together. So I would consider that. Not required, it just needs to be smooth. So if your welds are smooth, great. But if they're not, then hopefully you don't have to completely restart. So for this project, the size, the pieces or parts on this flash drive actually right here, they're already set. All you have to do is cut them out. So this video is going to walk you through how to operate this CNC machine, and there are 4 of these. 3 of them are the same, and then there's one that is larger, and it's sitting right and left rather than back and forth, but it operates the same way. So all 4 of these Shark Piranha CNCs operate the same way. They all have the same programming. Going to increase the size of this so that way you guys can see more what's going on. So with the CNC, you're going to walk up to it and you're going to shut it down to be at the same point. We are looking at a board. This is a sacrificial board. It's what gets cut into rather than us cutting into the table itself. This table cannot be destroyed. It is actually the frame. It's like a unibody on a car. It's the frame for the CNC itself. So it holds everything together. So I'm going to set my piece of aluminum down, which we have the aluminum right over here. If the aluminum piece that's already on here can get more pieces cut out of it, please use it up so that way we're using the entire thing. You don't have to put your pieces super tight together like what we tried to do on the Torchmate CNC table next door, the plasma table. Because this is a router, we don't want the router bit to come into contact with any of these hold downs. That's completely different than next door, so we're not trying to shove as many cuts on top of each other as possible to the point of doing damage to one of these tie downs here. We do want to get as much out of the aluminum as you can, but the router disc is very expensive, so we don't want to damage that. So step 1, I need to clamp this down. I'm going to clamp it down to where I have some wood exposed at the front. That's going to allow me to set the Z coordinates. There is a line drawn, a Sharpie line drawn on the bottom of this. That's about where you want to put the metal. You don't have to cover it up or be right on it. It's just, that's the extent. So there's a Sharpie line here and there's a Sharpie line at the back. This router can't go past those points. So I'm going to put all of the tie downs. The tie downs need to be on the aluminum about 1/4 of an inch. I'm just going to tighten them down just a little bit to start with. And if you need to, you can walk around to the back side if your arms aren't long enough to reach. We do want to get all of the tie downs put on. 4 tie downs is not quite enough. If something goes wrong, 4 tie downs will not be enough to hold this aluminum from moving. This is forcefully moving the router bit in the aluminum, so it's really trying to move it. So you're going to tighten these down. Notice how tight I'm tightening them down. I'm not killing it, I'm not putting my entire body weight into it, but I am going as tight as it will let me go without putting my body weight into it. So if you're significantly smaller than I am, then you need to take that into consideration, and if you're smaller, then you need to put the whammy on it, because it's going to equal about the same thing that I'm doing right now. Okay, this one has 6. I believe this one behind me only has 5 tie downs, which is fine. That has worked. I need to get more for that. So now the aluminum is locked down. It's going straight in the middle of the CNC machine. This is the track that all the cords run in. To turn this on, we have, because this box underneath here really isn't accessible with trying to keep it clean, keep it free from all the dust, metal, debris. We're using these surge protectors as our on and off and as the emergency stop. So at any point, if this is going bad, you're going to just shut the thing down with this right here. So I turn this on, the screen's going to pop on, and I'm going to move this a little bit closer so you guys can follow along. And you can pick this up if you need to. There's not really a need to do that, but if we need to, you can. So I click through that. You just do the exact same thing that I just did. I apologize for that glare. I'm gonna have to talk it out, I think, to keep, or so that way you guys can see it. I'm going to go to near Y, and I'm making sure that the Z coordinates, so this is Z up, this is Z down right here. So I'm going to bring that up, and you can see the router in the back going up. Now I'm going to bring this closer to me. Okay, now I'm going to drop it down. I'm going to get closer, then going right. I'm bringing it forward to where that board is, because I need to scrape the board just a little bit. So I'm getting within ½ an inch, and then I'm going to change. There's a fast button. I click it, it turns to medium, and then I click it again, and it goes to slow. Now I'm going to continue to go down, and I'm getting close. I'm getting my head close here behind the camera to where I want that router bit to barely touch the wood, and then I'm going to drag it to the right or to the left, and I'm going to see if I'm scraping the wood. And I can see I'm not quite scraping, so I'm going to go down one more click, and then I'm going to drag it. Okay, I can see that it's leaving a little scratch on the wood surface. So there's a 0 Z button right here. I'm going to click the 0 Z, click OK. So now my Z coordinates are set. I'm going to turn this button back to fast. Go away, and just like we do with the other CNC next door, the plasma cutter, we're going to start in the far left side of this. I'm bringing the Z coordinates down within an inch or so, just so that way I can see where I'm at. The way that the file is set up on this flash drive is that it's the router bit's actually going to move a little bit out and a little bit this way, so it's kind of outside of the 0, 0 coordinate. It's not all building that way, so I don't want to be super close to the edge. So I got it set where I wanted the 0 to go, and then I moved it forward and moved it to the right, just probably 1/4 inch. I'm going to 0 the XY. It says warning about to change the CNC axis. Yes, that's exactly what I'm trying to do. So I click OK then. I'm going to go into USB, And here's all of the jobs that are available on this USB. It's kind of hard to see on the screen for some reason. It's kind of behind this protective cover. It says top and bottom of 2-inch cube, and then it says sides of 2-inch cube. So you need 4 sides, and then you need the top and bottom. Those are the pieces that you need to cut out. So if I do top and bottom, if I load that one right now, hit next, it says file not referenced to center, press OK to run without virtual. We're not doing that, so we're just clicking through that. So at this point, I'm going to hit the start button here. That turns the router on. I just turned it off for the sake of this video. That turns the router on, so this router is running independently of this. However, the surge protector that I turned everything on with, if all of a sudden, oh no, it's crashing, the CNC did something wrong, like it can lose its Z coordinate, its point where it knows it's at, it might all of a sudden just dive down into the material. If it does that, you need to very quickly get this thing powered down, and that would be with the surge protector. Don't try to reach over and turn this off, because this is still moving it. It needs to all shut down all at the same time, and so that's how you do that, is just killing the power very quickly to the CNC machine. So you cannot walk away from this machine. We could, to some degree, walk away from the plasma cutter, because the plasma cutter would stop cutting, and then it would stop itself because it has that feature in it, and it works differently. The cutting head on it works completely differently. This is not the case. We have the machine that's going to tell this to move, and it doesn't have a clue what is going on with the router, so there's no safety feature. So we do turn this on to get the router to run, and then this is running it. We have to monitor that this is all going exactly how we want it to go. If it doesn't, we need to immediately shut it down. If you know what's going on, cool, you can fix it. If not, you need to get me, and I'll help you navigate what the next steps are. So when I go to start this, it would be router on, and then I click the start button, and it's going to start running. It's going to have 8 passes. The first pass should be very thin, like we're talking a 1/16 of an inch is all that it's going to do. So it's going to it's going to be on already, but it's going to be cutting, and it's cutting out the square, and then it's going to, on the second pass, it's going to dive down a little bit deeper, about another 1/16 of an inch, if not less, and then go around, and then around again, and around again, and around again. It's just going to keep going until it gets all the way down to the wood, and it's going to etch into the wood just slightly because I've set my Z coordinates to the height of the wood. When that is done, you want to go ahead and you're going to exit out of this. So that will be done. You hit the exit button here. Not sure that you guys can see that. So I hit the exit button there. So I'm back to here. I would need to set the 0 XY coordinates for the next piece. So I'd move it ahead. We'll pretend that I just cut out a square right here. So I'd move it ahead and cut out the next square above it. And then when that one's done, I'd move it to the next spot and then get all 4 pieces, and then I need to do the top and bottom. So then I'd do the top and bottom. When you get all of your pieces cut out, you're going to take this aluminum off, and then you're going to you're going to retrieve your pieces. There are tabs in every single one that you're going to have, so all you do is bend them left and right, spin it around, they'll break right off. You can grind the little tabs off of your piece, and you're good to go. If we did not have tabs on these pieces, this router bit would grab it once it got down, so like where it's almost broke free, and it would throw it. It would break this router bit, which is a $70 router bit. This router bit is very expensive, so we are aiming to protect it. That is a big challenge and a big thing that we need to do with these CNCs. But they do a great job, so we're going to carry on with using them. That is the conclusion of this video. I'm going to figure out how to turn off the camera.